Okay, so I'm going to go over some of the homework problems. We didn't quite get through everything in our class today, or rather we got through everything, but you might have just been a little bit short on practice time. So I'll go through all of these. If you want to skip through and just check your work, you can definitely do that too. So I'm going to start on the covalent Lewis structure side. The ionic Lewis structures you probably had enough time to do. I'll do the ionics that are on the back though. But so to start off, CH4. So for this one, we're going to start off by, let me just change my pen just a little bit here. Drawing a structure. Carbon always pretty much goes in the middle. We also know that hydrogen can never be in the middle. So it's going to look like this. Then we need to know how many total valence electrons would there be. Well, carbon's got 4, hydrogen's got 1, but we see that hydrogen, there's actually 4 of them. So 4 times 1, we're going to need a total of 8 valence electrons. Now the point of bonding is that every atom gets an octet. Well, in this case, carbon is the only one that needs an octet. I'll tell you why in just a second. But so we give 2, 4, 6, 8 valence electrons. Hydrogen doesn't get an octet because hydrogen can actually only hold 2 electrons anyway. So the last step here is let's check our work. 2, 4, 6, 8. It matches that number, so that's correct. So that's number 1. I'll do another one right next to it right here. So OCl2. So, like I said before, the least electronegative goes in the middle. If you were to look at an electronegativity chart, Cl is actually the least electronegative here. We did an example in class where oxygen was in the middle. I'll take either, but right now we're going to do Cl is in the middle because I think that's really how it should be. And then O would be on this side. Doesn't matter which side O or Cl goes on, or if it's on the top. We just know that this Cl is going to be our middle. So let's count up our total electrons here. Oxygen has 6. Chlorine has 7, but there's 2 of them. So 14 plus 6, we're going to need a total of 20 valence electrons. So let's go back up here. We know that each of these atoms needs to have an octet. That's the point of bonding, so we need to make sure everything has it. We can draw bonds between the atoms, and then we just go back and give everything these lone pairs of electrons, so that we've got 2, 4, 6, 8. Let's do chlorine. 2, 4, 6, 8. 2, 4, 6, 8. Now that everything has an octet, we can go and count them up and see if it matches this number down here. So we need 20 total. Let's see. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that's going to be our structure. This is correct. So I'm going to clear my table. Okay, so next up is SiO2. So silicon is the least electronegative, so that's going to be in the middle. And then there's only 2 other atoms. Let's count up our total electrons. Silicon is in the 4th group. It's right below carbon, so it's got 4 valence electrons. Oxygen is in the 6th group, so it has 6 valence electrons, or 16A. There are 2 oxygens, though, so we're going to multiply that by 2. So 2 times 6 is 12, plus the 4 we have here, we need a total of 16 valence electrons. So when I come back up here, to remind you again, the point of bonding is that every atom gets an octet. So we're going to put bonds between the atoms, and then to fill up the octets beyond that, we do lone pairs of electrons. So there's 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. So you can tell that I'm counting these two for oxygen and I'm counting them for silicon. But there's still only 2 electrons there. So when I go to count up, I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now 20 doesn't match that number. So what we have to do here, and I'm going to switch colors really quickly so that we can see this better. Let's do this with blue. What we have to do here is take away some of those electrons and make them into double bonds. So what I'm going to do is take these two and these two, and these 2 atoms are actually going to share those. Now let's count up our electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18. We don't have 16 yet, but we're closer to it than we were before. So what we can do is the exact same thing over here. Oxygen and silicon on this side are also going to share a bond. So let me cross those out. Okay. 2, 4, 6, 8, 10, 12, 14, 16. That's correct. So you, if you have an eraser, can erase them like that, though this isn't that helpful because now I'm erasing the black behind here. But you can get rid of those so that it looks a little bit cleaner. But regardless, if you do it and leave those squiggles there, I'm going to be fine with it. So let me clear this out of here. Okay, so moving on to our next one, NH3. This one comes up a lot. So nitrogen is in the 5th group, so that has 5 valence electrons. Hydrogen has 1 valence electron, but there's 3 of them here. So 3 plus 5, we're going to need 8 valence electrons. We now need to know, when we draw this, what goes in the middle. Well, we know hydrogen can never go in the middle. So nitrogen goes in the middle, and there are 3 hydrogens. Doesn't matter which side they go on, but this side can't be filled with a hydrogen because there's only 3 of them. So we're just going to leave that blank for now. So we know that everything needs an octet, except for hydrogen. Hydrogen can only have 2 electrons. So I've got 2, 4, 6. Nitrogen needs its octet, so we're going to put 2 electrons there. Hydrogen can only have 2 electrons, so these 2 are good for hydrogen. 2, 2, and 2. All right, this is the last step where we decide, okay, do we have the right number of total electrons? 2, 4, 6, 8. If that matches that, then we're good. So that one's right. All right, let's do the next one, PCl3. So let's count up the total number of electrons. Phosphorus, I'm looking at the periodic table, and that is right below nitrogen, so that actually has 5 valence electrons. Chlorine is in the 7th group, so it has 7 valence electrons, and there are 3 of them, so times 3. 7 times 3 is 21, plus the 5 there, this is going to be 26 valence electrons. So when we're deciding what goes in the middle, well, phosphorus and chlorine, they're in the same group, or sorry, the same period. It looks like this. We've got phosphorus, in between that there's sulfur, and then there's chlorine. And we know that electronegativity increases this way. So phosphorus has to be in the middle. It's less electronegative. I'm going to draw our 3 chlorines around it. Okay, now every atom needs an octet. We're going to first start with making the bonds, and then let's go and give enough electrons so that everything has an octet. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Okay, now everything has an octet. I'm going to go and check my answer. Do I have this many electrons? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So that is correct. Okay, I'm going to pause the video real quick and clear this. All right, number 6. So number 6, we've got H2S. Oops, I need to have a color here. Okay, so hydrogen, we've got 1 valence electron, but there's 2 of them, so 1 times 2 is 2. And sulfur, sulfur is directly below oxygen, so it has 6 valence electrons. It's in group 6. Least electronegative. Hydrogen is the least electronegative, but we know it can never go in the middle. So sulfur goes in the middle, and there are 2 hydrogens on either side. Everything needs an octet, so we've got 2, 4, 6, 8. I would give the hydrogen an octet, but it can only hold 2 electrons, so actually we're good there. And so let's count up. We need 2 and 6, so we should have a total of 8 valence electrons. 2, 4, 6, 8. There it is. We're good to go. So that's the correct answer there. The last one is CF4. Carbon gets 4 valence electrons. Fluorine gets 7, but we know that there's 4 of them. 7 times 4 is 28, plus these 4. This is 32 valence electrons. What goes in the middle? Well, it's got to be carbon, because it's the least electronegative. Also, carbon's pretty much always in the middle. Okay. Now, everything needs an octet. Carbon's good because it's got 2, 4, 6, 8. Fluorine, though, we need to go put enough electrons around it to get 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Okay, now, last step. Let's count up our total electrons and see if it matches this. 2, 4, 6, 8. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So that is now correct. All right, I'm going to pause this video because that's about the maximum, and then I will show another video for the back side of the homework.